In this video, you'll learn about laser welding basics and the parameters that you can control to create consistent, high-quality welds. All users must review the user guide in its entirety and be fully trained before using LightWELD. Make sure to review all the safety information in the user guide. Do not operate without both the IPG welding helmet, with shield provided with LightWELD, and proper safety glasses, certified for approximately 1070 nanometers. Make sure everyone present during laser operation is also equally protected. First, we will cover some laser welding basics. LightWELD generates two laser beams, a low-power guide beam that is visible for part alignment, and a high-power welding beam that is invisible. Be sure to always wear laser safety glasses certified for approximately 1070 nanometers when operating LightWELD. Additionally, always make sure to use the IPG welding helmet with shield provided with LightWELD when welding. The high-power beam creates a liquid melt zone. As you move the laser beam, the melt zone moves along the seam. The liquid metal from each side of the seam mixes to form the solid weld zone. Now, we will go over some of the basics about parameters and controls. LightWELD delivers laser power in different modes. You will be learning about continuous wave and pulsed mode in this video. In continuous wave mode, CW, the laser is on constantly while welding. LightWELD laser power can be adjusted from 150 to 1500 watts to best match your application. When welding at a given speed, increasing the laser power will increase the penetration depth. To maintain a given penetration depth, increase the laser power to increase your welding speed. Next, you will learn about welding in pulsed mode. In pulsed mode, PM, the laser is on for short periods while welding. These pulses create lower energy and a smaller weld pool, as well as creating less part distortion or deformation. Pulsed mode is useful when welding thin materials or for slow welding speeds. In pulsed mode, laser power can be adjusted as usual from 150 to 1500 watts. The pulse rate, the number of laser pulses per second, can be adjusted using the frequency control up to 500 Hz. Wobble welding increases the weld seam width up to an additional 5 mm. When the wobble length is set at 0, the laser beam is fixed on axis and creates a 0.3 mm wide weld pool. As the wobble length is adjusted up to 5 mm, the laser beam scans from side to side and creates a weld pool of similar width. Longer wobble lengths are useful for wider joints. You can also adjust the wobble frequency. This is how fast the laser beam is moving side to side. When the wobble frequency is set at 0, the laser beam is fixed. As the wobble control is adjusted up to 300 Hz, the laser beam scans from side to side faster. Faster welding speeds require higher wobble frequencies. Thicker materials require lower frequencies. Please note that setting the wobble frequency incorrectly may increase welding spatter and reduce weld quality. The preset modes provide optimum wobble settings while allowing you to make adjustments as needed to achieve the best quality on your parts. This concludes laser welding basics and parameter settings for the LightWELD 1500. Please watch our other videos for additional operating instructions and laser welding tips.